Welcome back. So this is the videos for 7.5 and 10.2. There's already been 2 videos, part 1, part 2. This is part 3. So if you haven't watched the first 2, definitely go back and check them out because it definitely breaks down the essence of simplifying radicals. Okay, so let's go to question 8 and see what we got. So the first thing that we do is do a factor tree. Now 150 is 15 times 10. 10 is 2 times 5. Those are both prime. And this is 3 times 5. Cool. Now I'm going to rewrite this. Now I put like things next to each other. So I want the 5 sitting next to each other so I can see that pair readily. Okay? So we have 2 times 3 times 5 times 5. And don't forget that little x. Cool. We have that x sitting there. So we're looking for sets of 2. Although we don't see the root, if we don't see the root, it's always asking us to look for sets of 2. 2 things that look exactly alike. You have no pairs, you have no pairs. I found one. Bloop. Mr. 5 gets to leave. Does he get to leave? He doesn't have a pair. He's a single x. We can only leave in sets of 2 things that look alike. So the 5 will stay on the outside. 2 and 3 stay on the inside, but we're not going to write 2.3. We're going to multiply it. We're going to clean that up a little bit. 2 times 3 is 6, and we have a single x. And again, the radical should not be a short one. It should be all the way covering everything on the inside. Cool. Again, my suggestion at this point, there's only 1, 2, 3, 4, 5, 6, 7 questions left on these in-class notes. I would suggest you try it on your own, and then pause, and then come back, okay? Because I'm going to lickety-split do the rest. Okay, so here we go. Question 10. We're going to break, shenanigans. We're going to break down 48 into a factor tree. I know it's 4 times 12. That's 2 and 2. That's 4 and 3. And that's 2 and 2. I have all my beautiful primes. It might help if you used a multiplication chart too, if that makes you feel more comfortable about the math facts. So we have 2, 2, 2, 2, 3. 2, 2, 2, 2, 3, and we have 3 p's. Bloop, 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 bloop. And that's a big product. That means it's a giant multiply question. This thing and this thing, absolutely equivalent. Now we're going to look for our sets of 2 because our root is 2. If we don't see the root, it's 2. So, got one, got another one. Ooh, got a little set of p. And now you're like, ooh, what's left? Sometimes I think it helps as if you circle what's left, it stays. Okay, so I have 2 times 2 on the outside, which is a 4, 4p. So we're going to have 4p on the outside, and then who's left on the inside? A 3p. And make sure that vinculum's nice and long. That radical is nice and long to cover that 3p. Cool. How'd you guys do? Nice. So I'm going to erase and scooch all this up, and we'll do the last 6 questions. Perfect. I did do those. Okay. And I did do those. Last 6 questions. Let's see how you guys do. Okay. So you should have already tried these on your own. Use a factor tree, break it down. Now you can see that this level gets a little bit more spicy. I've added 2 types of variables now. And down here, 3. So just leveling up, you know, gotta spice it up. I know that 8 is 2 times 4, and that's 2 times 2. So 8 is the same thing as 2 times 2 times 2. Let me write that out as a product. I have 2 A's, and I have 2 B's. Cool. And I'm looking for sets of 2 to leave the radical party. You get to leave. You get to leave. You get to leave. You had to stay behind. Why did that 2 have to stay behind? Right, he's a single 2. He didn't have a partner. So we have 2AB on the outside. It should be number first, and then the letters, I say alphabetical order just because it's, well, nicer looking. And we have a radical because we had somebody left. Bloop. Final answer. Cool. Let's try this one. 75 is the same thing as saying 3 times 25, and 25 is 5 times 5. So we got our primes. So 75 is the same as saying 3, 5, 5. 3 times 5 times 5. Don't forget our variables. 2 x's, done. 2 y's, done. And now we're looking for sets of 2, because our root says look for sets of 2. If by the way, it said sets of 3, no one could leave. There's no set of 3. But that's the only difference. Instead of looking for 2 that are the same, you would look for 3 that are the same. But the only way that can be 3 is it has to show itself. The only root that's allowed to be invisible is the root of 2. Okay? So here we go. Gotcha. Gotcha. And gotcha. So I have 5xy on the outside. And I got a little 3 left behind because it didn't have a partner to leave with. And shoot, while we're here, let's just do this little beast. Actually, no, we'll go over here. 144. Now, I know that 144 is a perfect square. It's 12 times 12. So I have my pair. That is a perfect square. So if you don't see that, you're going to do a lot of math because you don't see that. Knowing our perfect squares up to 20 times 20, which is 400, is really a valuable thing to do, right? And again, I have a poster on the wall. So 19 times 19, 361. 18 times 18, 256. I have this great poster, 324. I have this great poster up here. So give it a go, okay? So here we go. I'm going to cheat on the breakdown a little bit because I know that 144 is 12 times 12. And then I have a couple A's and a couple B's. So the 12s get to leave, the A's get to leave, and the B's get to leave. Wow. Because our root is 2. Nobody's left behind. So that means our final answer will not have a root. Okay? So 12AB is our final answer. Done with no radical because no one was left behind. 8. At this point, I think we should have this memorized. 8 is 2, 2, 2. After a while, you do start memorizing these because they're just in everything. We have 3 X's and we have a single Y. Remember, if we don't see a little power on it, we know it's a 1. So we have a set, and that's it. 2 had no partner, X had no partner, and Y had no partner. So we have 2X on the outside, and we have 2XY on the inside. Make sure the top of that radical is nice and long to cover everybody. Cool. How'd you guys do? Great. Now again, if you haven't tried the last 2, give it a go. Why not? Give it a go. Hopefully you have an eraser. If you make a teeny mistake, that's fine. This one, we have more variables. Our numbers are pretty decent. So give those a go. I'm going to erase the board and push these up a little bit. Okay. Last 2. Let's see how you guys did. So 48. If we break down 48, it's 12 times 4. And 4 times 3, 2 times 2. 2, 2, 3, 2, 2. Cool. Make it nice and long because we got a lot of people at the party, if you know what I mean. So we got 2, 2, 2, 2, and a 3. 2, 2, 2, 2, and a 3. Notice I put the like numbers together. That's easier to find our pairs. We have 2 A's. Bloop, bloop. We have 3 B's. Bloop, bloop, bloops. And we have 3 C's. Bloop, bloop, bloop. And now we're looking for pairs. Gotcha. Gotcha. That would be a no. Gotcha. Uh-huh. No. Gotcha. Wowzers. A lot of people left the party. We have 2 times 2 is 4, A, B, C. 4, A, B, C. And let's see who's left over. Be real careful. A 3, a B, and a C. Legible writing is going to be imperative on this one. So make sure you're writing, well, neatly. If not, this isn't going to work. Last one. We have 16. 45 breaks down to be 5 and 9, and 9 is 3 and 3. So we have our primes, 3 times 3 times 9. So let's rewrite our radical. 45 is the same thing as saying 3 times 3 times 5. And we got a couple M's, 3 N's, and 3 P's. Cool. It's a big product. That means there's a little multiplication dot between everybody. And our root is 2, because it didn't show itself. We know if it doesn't show itself, it has to be a root of 2, or we're looking for pairs. See ya, Mr. 3. See ya, M. See ya, N. And see ya, P. On the outside, we have 3MNP. 3MNP. And on the inside, Mr. 5 had to stay. He had no partner. Mr. N had to stay. He also had no partner. And Mr. P. Cool. Final answer. Nice. Well done. So I'm going to end the video here, but we're not done. Remember, this is a 2-part lesson. So we're going to have another video, video 4. So come back for that. Have a great day.